Good morning, good afternoon, and good evening, wherever you may be in the world. This is the Euclidean geometry section of our mathematics exam preparation series, and we continue with our paper 2 exemplar paper that we have been using up to this point. And to start us off in this topic, we are dealing with question 9. Okay, and we have two questions under question 9, A and B. So let us take a look at question A. Here it is. Alright, so we need to talk about similarity of two triangles, triangle ABC and triangle DEC in the diagram. Now, my recommendation is to always fill the diagram with as much information as possible that is based on theorems, that is based on valid mathematical concepts, okay, not just assumptions that have no basis. Alright, so they should come from some sort of properties, concepts, knowledge points that we have learned under this topic. Alright, we have a circle and we're given a center. Clearly there is a diameter because we're told that BA is a straight line passing through the center A. So that and that, BA is equal to AE, they are radius lines. AC is also a radius, okay? So we also know that CD is equal to DE. Why? Tangents from the same point. So we have three isosceles triangles in this diagram. What can we do now? We know that this angle is equal to that angle, right? We also know that this angle here is equal to that angle. And we have, lastly, I'm going to use 3 arcs this side. That angle is equal to that angle. Okay, so we have made the connections on the diagram, so we just have to now structure it properly using the right mathematical language, statement, and reason type of setup. Okay, so what do we know? We know that E2 is equal to angle C3, okay, because of tangents from the same point. Spoken about this too. However, by the 10 chord theorem, right, the angle between the tangent and the chord, yes, is equal to the angle subtended by the same chord in the alternate segment. So C3 and E2, now we connect them to B. But angle E2 is equal to angle B. This is also equal to angle C3, right, by the 10 chord theorem. Okay. Now, what are we going to do from now? We're going to connect these two. We know that angle B is also equal to angle C1 because these are angles opposite equal sides. Okay, so angle B is equal to angle C1, angle B is also equal to C3. So we've connected these two angles here in the two respective triangles. Okay, so therefore angle C1 is equal to angle C3. Okay, what do we then need to show? We also connected this two. Okay, E2 is equal to angle B, that was shown. Okay, and lastly we need to connect these two guys here. Angle A1 is equal to angle D by sum of angles in a triangle. So therefore angle A1 is equal to angle D by sum of angles in a triangle. Therefore we can conclude and write the last line. Triangle ABC is indeed similar to triangle DEC, okay, by angle condition of similarity. Okay, or you can simply write equiangular triangles. That is also equivalent to writing this. So this takes care of question A. Let us now take a look at question B. Here it is. Right, so this is a follow-up question from A, where we are required to prove that the product of AE and EC is equal to the product of BC and DE. Okay, so from the previous statement that we made, so we write, since triangle ABC is similar to triangle DEC, we can now introduce proportionality of sides because we've proven similarity of the triangles. Okay, so AB over DE is equal to BC over EC is equal to AC over DC. Okay, what are we looking for? A product that contains AE and EC. Okay, we don't have AE, but we have AB times EC. We can cross multiply there, and BC times DE, that one we have. So we're going to exclude that in where we're going now, or in the next step, right? So therefore, we have that AB times EC. Okay, what is the reason for this statement? Similar triangles. So we have AB times EC is equal to BC times DE. We need to fix this guy to be like that guy. How? We go back here. AB is a radius, AE is also a radius. So that is what we know. But AB is equal to AE. They are radii. Okay? So then we replace AB with AE. Therefore, AE times EC is equal to BC times DE. Okay, easy 3 marks to collect, and this takes care of question B. Right, so now we are going to question 10, which also talks about, some more challenging Euclid problems. I'll see you in that next video. Sharp, sharp.